All right, so here's page 2. Okay, a particle travels from A to B following the function x of t equals negative 4t plus 3t squared minus t to the third. Okay, so since you see this t to the third, you know that this is not going to be a constant acceleration. Okay, that the acceleration is going to also be time dependent. Okay, and in that case is when we're going to have to use calculus. Okay, so the v of t is the derivative of x with respect to time. Okay, so this is just going to become a negative 4, right? Because we're going to drop the 1 and then drop that down to t to the 0. Okay, here we're going to drop down the 6 and then subtract 1 off here. And then here we're going to drop down the 3 and then subtract 1 off. Okay, the acceleration is going to be the derivative of the velocity with respect to time. Okay, so again, the constant goes away. Then I've got 6 and then minus, I'm going to bring this 2 down here, 6, and then drop the exponent by 1. Oops. Okay, all right, so there's the acceleration. Okay, the instantaneous acceleration at 6 seconds, all I'm going to do is I'm just going to plug in a 6. Okay, so that's going to be negative 30, and it's probably meters per second squared, even though it didn't say. All right? Okay, this one, a particle follows this function. This one's a little bit trickier mathematically, but conceptually it's fine. Okay, and the first thing I'm going to do is I'm just going to rewrite this exponent as t to the negative 2. Okay, because that's a little bit cleaner. All right, and then I'm going to take the velocity is the derivative of position. Okay, the constant goes away. I'm going to drop down the negative 2 to become positive 8.4, and then I'm going to drop the exponent by 1, and then plus 5. Okay, and then the acceleration is going to be another derivative. I'm going to drop the negative 3 down, and that was going to be negative 25.2 t to the negative 4th. Okay, and then the plus 5 is a constant, so that goes away. All right, and then the instantaneous, all I have to do is plug it in correctly, not like I did the first time. Okay, so that's 8.4 over t cubed. Okay, so that's 8.4 over 8 plus 5. Okay, and then that's going to come out to be 8.4 divided by 8, 1.05 plus 5, so 6.05, probably meters per second. Okay, and then the acceleration at 2 seconds, same thing. Okay, I'm just going to plug in the 2. Okay, remember the negative exponent goes to the bottom. 25.2 over 16. 16 is 1.58 meters per second squared. Oh, negative. So it's negative. Okay, and that's that.